Hey all, I just want to go over some extra examples of finding distance or length of segments in the coordinate plane. And so one way that we did that was by having a segment in the coordinate plane. And I have to name the points, find their coordinates. So this one is -3, 2. I call that x1, y1. And then this one is 4, 4. Call that x2, y2. And remember, we're using the Pythagorean theorem, so I always write that a squared plus b squared equals c squared. Because I can make this a right triangle where this side is a and b and c is my segment length. And then in order to get a, I subtract the x's, keep the squared. To get b, I subtract the y's, keep the squared, and I change c to d for distance. And so here my x's are -3 and 4, so I'll subtract them. -3 minus 4 squared. My y's are 2 and 4. I'll subtract them. 2 minus 4. Keep the squared. -3 minus 4 is -7. 2 minus 4 is -2. And now we have to square these. Remember, when you square any number, you're going to get a positive answer. So -7 squared, or -7 times -7 is 49, positive. -2 squared is +4. And then the last thing we have to do is get rid of the squared on d for distance. Square root both sides. And we'll get d equals, and I'll do the square root of 53. It is about 7.3. That means this segment right here is about 7.3 units long. So if I laid it flat and I started there, I'd go 1, 2, 3, 4, 5, 6, 7, and then a little more, and it would be that long. You do one more like that. Get my coordinates. -1, 2. Call that x1, y1. 1, -5, x2, y2. It's important to make sure that you're getting the correct coordinates. I'm using the Pythagorean theorem, so I'm writing it every time, and then I'll remember it. To get a, I'll subtract the x's. To get b, I'll subtract the y's. And then I like to change c to d for distance. We're looking for the distance between those 2 points, or the length of the segment. It means the same thing. So I change c to d. If I subtract the x's, I'm doing -1 minus 1. When I subtract the y's, I'm doing 2 minus -5. Here I get -2, and I get 7, which I believe is the same thing we got up there. So we're going to get 4 and 49, and I get 53, and I do somehow get the same one. So I'm going to square root both sides. Square root of 53 is approximately 7.3. So again, this segment is about the same, or is the same length as the one up here, and they actually kind of look like that. They're just slanted different in the coordinate plane. Again, it would be 7.3 units long. So I want to do a couple where we don't have the picture. We can still find out the length of the segment between these 2 points, or how far apart they would be, the distance between them. We label them x1, y1, x2, y2, just so that we know which numbers are x and which numbers are y. and then we're going to write Pythagorean theorem, and then we're going to modify it for ourselves. A is subtracting the x's, don't forget the squared. B is subtracting the y's, don't forget the squared, and we change C to D for distance. My x's are -10 and -6, so I do -10 minus -6. My y's are -6 and -10, so I do -6 minus -10. -10 minus -6 is going to give me -4. Again, use your calculator if you need to. -6 minus -10 is going to give me +4. So I'm getting a -4 squared and +4 squared are both going to be 16, +16. Oops. So I get 32. And then I need to square root both sides to get rid of the squared on the letter D. And the square root of 32 is about 5.7. So if I were to draw or plot these points in the coordinate plane, the distance between them would be about 5.7 units. So just a little less than 6 units. It would also be the length of a segment that I could draw between these 2 points. So let me do one more. Again, if I want to know how far apart these are, I'm going to start by labeling them x1, y1, x2, y2. I'm organizing my thoughts, writing the formula I'm going to use, which is Pythagorean theorem, and then modifying it to say A is subtracting the x's, B is subtracting the y's. And I change C to D for distance. So when I subtract the x's, I'm doing -8 minus -8. When I subtract the y's, I'm doing 8 minus -3. So here I actually get 0. And here I get 11. 0 squared is going to go away because 0 times 0 is just 0. And 11 squared is 121. I'm going to square root both sides. That cancels out the squared on D for distance, and I get square root of 121 to be exactly 11. So these 2 points are exactly 11 units apart. If you were to put it on the coordinate plane, they would be 11 units apart. So there's 4 examples for you. If you still need some help, make sure you ask for help. Good luck.